Okay, this is the study guide video plus extra credit. As many times as you do these, I'll give you a point back towards your grade. Make sure you write down the 5 words to finish the deal. Show me you were listening. So here we go. For this guy, I'm taking -4 and I'm plugging it in for x. To show it, I show it like this. F of -4. I plug that -4 right here where x is. I do the timesing first. That gives me -12. And then when I combine that with that -7, that gives me f of -4 equals -19. That's going to be the complete answer. For this guy, I'm plugging in D right here, and I'm following order of operations. So that's going to be C, and I put that 4 right there to show the number I'm plugging in. 25 plus 10, and I put that D right here. First random word is surf. Thanks for listening. So again, for this problem, don't do the adding, do the timesing first. Make sure you times that 10 and 4 first, and then you could add that 25. So that gives me C of 4 equals 65. So that's the one that you're going to circle. That's the one that you're looking for. All right, moving on. This guy, plotting using only the x and y intercepts. Only the x and y intercepts. So for this guy, I'm taking this 3 and I'm putting that 3 on this y axis. And then from there, I look at this number, this -3, and if I write that as a fraction, that tells me every time I go over 1, I'm going down 3. Right 1, down 3. This is where the coordinate's going to go. But remember, on this problem, make sure you only write these 2 coordinates. And then get a nice straight ruler. And with your straight edge, draw a nice straight line through both those. And then practice drawing arrows on your lines. All right, here we go. This one wants you to plot only the solution point. Only the solution point is supposed to say. Plot solution point only. So for this guy, if I'm doing that, I'm going to graph this first one here in red. This is -1. That's going to be down here on the y-axis. And then I look at this number right here. If there's no number there, that's a 1. If I write that 1 as a fraction, that's going to be 1 over 1. That tells me from that red dot, every time I go right 1, I go up 1. That's where my next dot goes. Right 1, up 1, right 1, up 1. Be able to stair step the opposite way. Draw that line. But remember this one, I'm going to go back and erase all that stuff. For this one, next one, +1. And then if I look at this number in front of x, which is -1, that tells me that -1 written as a fraction is right 1, down 1, right 1, down 1, right 1, down 1. And I could see right there is where they intersect. Right 1, down 1, right 1, down 1, right 1, down 1. You can be able to stair step opposite. But remember, for this guy, this is my solution point right here. That is this point over 1, 0. That's my point. So to get this one right, I'm going to erase all this stuff and only have that point. So again, all these extra points, I'm going to use my computer to unclick them. And I'm going to make sure on my computer I only have that one coordinate. And again, that is my answer right there. That's the graph with just that coordinate right there. All right, second word is wave. Thanks for listening. All right, for this guy, I'm looking for increasing sections where it's going uphill. So I have this section going uphill, this section going uphill from left to right. That's how I look at it. And then I use these numbers on the x-axis to describe those sections where it's going up. So that's this guy right here. And then I look at those numbers on the x-axis, that -5 and that -2, and I can see that's this one right here. Again, looking for the two best answers. This one, decreasing. Decreasing is where I'm going downhill. Here are the two downhill stretches using that same -2, but then this number right here, which is 0. So that's this guy right here, from -2 to 0. That's one stretch. It's going downhill. Another downhill stretch from this 4 to this 7. All right, and then for this, which statement is true? So if I look at this one, the maximum at over 2 up 7 is saying that right there. That is false. This one's saying the minimum is at 6, 7. That's false. This guy's saying the minimum of -6, 7, which is right there. That's false. But this guy, if I look at it, this one is true. This one has a maximum of left 2 up 7. That is this point right there. That is the maximum. So that is true right here. All right, next, moving on. Interval notation using symbols. So here I go. This one, when I do domain, domain is measured from left to right using the X numbers. So if I look right here, 1, 2, 3, 4, 5, that's -5. This is closed. So I'm going to write it with a square bracket. So square bracket on that -5. And then this arrow, even though it's going to the right, that is positive. Positive. Even though it's going to the right, that's positive infinity. And then this is rounded. All right, range is from bottom to top using the Y numbers. So for this guy, there is no bottom to it. That's negative infinity. So for this one, rounded negative infinity. And then I go up that Y-axis and I see what that is. This is closed up here. That's going to be closed. So that's on 4, square bracket. All right, moving on. The equations page, I believe. Here we go. For equations, first thing I'm going to do is distribute and then combine like terms. So if I distribute, that gives me -10x plus 15 plus this 3x equals -2x plus 5. And then right there, I'm going to combine my like terms, and that's going to give me -7x plus that 15 equals -2x plus 5. And then I could see right there, that is my key variables on both sides form. So I'm going to start with getting rid of the -15 on the left. That's going to bring down this -7x, this equal this -2x. And then be careful right here. This right here on my calculator gives me -10. And then I'm going to stay on this side and add that 2x. Key step right there, the separation step. And then again on my calculator, be careful. This is a negative situation. That gives me -5x. And then the last little negative situation, I'm dividing by -5. And then again, one last negative situation. That one gives me +x equals +2. So again, positive whole number. All right, third word is pelican. Pelican. Thanks for listening. Third word. All right, so for this guy, I'm adding 3. I'm going to bring down that 2x. I'm going to bring down that inequality. This gives me 20. And then I'm going to stay on this side. And the opposite of timesing 2, dividing by 2. And that gives me x less than 10 for this one, if I could write that neatly. It's all you have to do. All right, for this guy, solving for this h. So first thing I'm going to do is have you flip it. So that gives me 6h plus 60 equals p. And then just like a two-step equation, start by getting rid of this 60. When that goes away, make sure you write this correctly. That's 6h equals positive p minus 60. So really watch that. Really watch that. You made that positive p and you made that negative 60. And then my last step, dividing by 6. Everything dividing by 6. So I'm dividing this by 6, and that gives me just plain old h. I'm dividing this part by 6, and I just write that p over 6. And then the tricky part, I'm dividing this negative 60 by 6, and that gives me negative 10. So be careful with that one. All right, moving on. For this one, looking at which one is functions, which one are functions. So again, on this one, the key, look at the x numbers. If none of them repeat, don't even look at those y numbers. If none of those x numbers repeats, it's a function. If you have an x number repeat, and again, spit out 2 different y numbers, that's the key look of bad data. You can't have the same input spit out 2 different outputs. If I look at the other ones, none of these x numbers are the same. So even though all these are, don't look at those. This is key. None of these x numbers are the same. Positive is not the same as negative. Those are good. All 3 of those are good. But then remember, the next one says select one that is not a function and explain how you know. So I'm going to use complete sentence. The second set is not a function because a x number gives 2 different y numbers. Make sure you put that period in there, and then maybe show me those. That's that 2, 6. Show me the ones you're talking about. That's that 2, 5. All right, next one. This one's saying which one is not a function. So again, read what they're asking. So which is not a function? All these x numbers, they don't repeat. That's a function. If I look at these, none of these are double arrows. Remember, you're looking for double arrows to make that bad, but none of those have double arrows, so this one's good. And then if I look at this guy, these are like my x numbers. These are my y numbers. I have a 2 and a 2 spit out 2 different numbers. And again, can't have that. So that's the bad one. So explaining one, that's not bad. I could say the table is not a function because a x number gives 2 different y numbers. And then maybe write the ones they are for this one. 2, 5, that's no good. And then 2, 4, can't have the same x number, give you 2 different y numbers. That's not a function. All right, here we go. Moving on. Number 11, 12. For this guy, all it wants is the domain. The domain are the x numbers. So if I look for these points right here, the X numbers, I got a 1, I got a 3, I got a 5, and I got a 6. All I got to do is list them. So 1, 3, 5. All the X numbers, not these Y numbers. All right, next, this one would show a domain of 2 positive infinities. So this is going to be closed circle. So here I go. This one, because it's open, no good. This one, because it's starting at 1 or 0 right here, makes this no good. This guy right here, because it's starting at 2, and that's closed, and this is going to the right, that's 2 infinity. So there we go. That one is the first of 2. Remember, there's going to be 2 of these. If I look down, this one right here has an open on that 2, so that would be 2 infinity rounded. That's no good. If I look at this guy, this one has negative infinity because it's going to the right, 2 square. That's no good. But if I look at this one, has a square on the 2, and then again, this is going to positive infinity. So positive. That's what makes this one good. Even though it's going down, it doesn't matter. It's going from left to right. That's positive. All right, moving on. For this guy, they want 3 words that explain this graph. So here we go. This one saying continuous. That means no dots. And I could see this has no dots. Discrete, that is when you have just dots. So that would be like this. All right, decreasing. This one is no good because decreasing would be going downhill like this, and that's no good. Exponential, that's another word that matches this because this is curvy, curve. Increasing is the third one because this is going uphill. And then linear is no good. Linear would be if it was straight. This is not straight. All right, moving on. Here we go. 15, and the fourth word is seal. Seal. So for this guy, they want to know if it's geometric or arithmetic. For this one, if I look at this, I have negative 56, and I'm going down by little. So this one, if I'm looking at it, this is going to be arithmetic. This guy right here, if I look, this is big, big, big right here, big gap. That one is going to be geometric. Or again, key, look at that negative. If you see a negative there, arithmetic. If you see no negative, it's going to be geometric. All right, here we go. Almost done. 16. For this one, if I look at it and see a percent, remember for review, that's exponential. So I put number 1 right here. If I look at this one, I have another percent. So that again is going to be one of those curvy graphs. So I put number 2 in there. If I look at this guy right here, no percent. So this one is just adding 1/3, just adding 1/3, just adding 1/3. That's straight. So I put number 3 in linear. Remember, exponential is curvy. Linear is straight. All right, moving on. These two, you got to do some work. So if I look at this one, I got 1 hour went 5. 2 hours went 8. 3 hours went 12. And if I look, this is going up by 3. And then this gap right here, since it's not the same, makes this neither. So I put number 4 in neither. Just remember, if this was +3 right here, I would have put 4 in linear, but it wasn't like that for this problem. This one was neither. And then this guy, next one, I do a little bit of work. I take this 40 and this 2, $40 divided by 2 hours. That gives me $20 for every 1 hour. Then I look at 60 divided by 3, and if I get the same answer, that's going to be linear. If I get, I'm sorry, this is 3. If I get a different answer, that makes that neither. But for this one, I can see that one for sure is linear because these are the same. All right, last problem. Here we go. For this guy, you're looking for those changes. So let's look. For this pattern, I have the first one starting where this side is bigger. If I move down, that pattern's still going. This side is still bigger. But then when I move to here, still bigger. No switch. But now for this next step, now right here, now this side is bigger. So at that switch, that happened between these two numbers on the x-axis, on the x column. That's going to be my first switch right there. So I use these two numbers to describe that first switch. So I got from -1, inequalities always go this way, and I got my 0 right there. And then if I look, the pattern, now this is bigger. But then if I look right here, now this side is bigger. Remember on a number line, -3 is closer to 0 than negative. So we gotta know that. That's why 3 is bigger. And then if I look at this guy, this is the bigger number right here. Because remember on a number line, -6 further away from 0. So this is the switch right here. And then I use these two numbers on the x-axis to describe the second switch. So 2 right, that first number. X inequalities always go this way, and my 3. All right, last word is fish. Fish. Thanks for listening again. Each time you write these, I'll give you an extra credit point. Good luck.